Greetings. This is Unit 7, Module 4, Session 3. The name of this home connection is the Unit 7 Review. It's a 2-pager. Make sure you put your name and number on it. So we're talking about the function machine, and we need to set up these machines to do exactly what it says. For example, on 1A, it says, set the function machine's controls to multiply each input number by 4 and then subtract 2. One has been done for you. You get to choose and write in the last 4 input numbers yourself. So yeah, you get a little choice here. So as I look at this machine, we're going to zoom in even farther. We said that the goal is to multiply by 4 and then subtract 2. So with this first number 3, they multiplied it times 4. Okay, that would have been a 12. And then they subtracted 2 to get 10. Okay. If that's true, we should be able to identify what the next one is, because we would multiply 4 times 4. That equals 16, and we're still going to subtract 2 from it, which gives us 14. And you write that here. Let's do another. The next one is 10. Still going to take it times 4, because that's what the machine tells us to do. Well, that's 40. And I still subtract 2 because that's what the machine says to do. That would be 38. If I continue down the list of functions or numbers in our machine, 2, once again, everything's going to be times 4 and then minus 2. 2 times 4 is 8, and then we subtract 2. Well, now we have an output of 6. Now, if we input that 6 back into the machine, once again, take it times 4. 6 times 4 is 24. Still subtracting 2 gives us a 22. Input of 24, we take that times 4. That might be where you break the numbers up, where you take 20 times 4, which is 80, and then 4 times 4, which is 16, and then you add them together, which would be 96, okay? So we know that 24 times 4 is 96. Still going to subtract 2 from it and get 94. In this machine, you get to put in the last 4 numbers. You put in whatever you want. Just make sure whatever you put on this left side that you take it times 4 and then subtract 2. So you're going to get a lot of freedom on this assignment because there's so many blank spaces. I would just like to double check this one here. 2A says, now set the machine's controls to make each output number 5 times as much as the input number. One has been done for you. So in this case, the only thing that they want you to do is take the input number times 5. So whatever's on the other side, you're going to take times 5. Now, because you're multiplying double-digit numbers, you might be tempted to maybe take 15 times 5 and do the standard algorithm. That's fine. 5 times 5 is 25. Carry the 2. 5 times 1 is 5. If you add the 2, that would be 7. So we know that the output here is 75. All of these numbers we're going to be taking times 5. Every single one of them. And I'm going to give you an opportunity to get lots of practice in on this machine, okay? And don't forget to fill in the last one yourself. I will say, though, on this one, sorry that this is all jumpy. I'm just going to write this down just so you have something to look at. Like 20 times 5, that is 100. I'm hoping you notice a pattern here, is that as you increase by 5 each time, how much are you increasing on the other side? Looks like a plus 25. Looks like a plus 25. So you could do the standard algorithm or maybe grouping and multiply all of them out. But since we're adding 5 each time on the left, you could just count by 25s on the right. I'm going to leave that up to you. In B, it says choose the equation that represents the rule above. We said take times 4 and subtract 2, so I'm going to let you choose that one. On the right, it says describe two different patterns you notice about the output numbers. We already kind of wrote those on the side, didn't we? Okay. Here are multiplication problems that they just want you to do. One thing to remember is that, and I'm trying to get a color here that I like. If I ignore these zeros, that's kind of not what I wanted to do. So let me try that again. If I ignore these zeros, pretend they're not there. 4 times 8 is what? Hopefully you're saying 32. Now I'm just going to take those 2 zeros that I forgot about and put them back on. So the answer is 3,200. So our strategies with zeros are very important here. I can do the same thing here. I can just kind of forget those are there and then add them when we're done. Okay? Same for here. I can forget about these zeros, multiply, and then put both of the zeros back on. Same here. Forget they're there, and then put them on when you're done. Same thing here. Forget they're there, and then put them on when you're done. And that's that whole page. So I'm going to let you do that. Pause this video, finish those, and meet me on the next page. Marco says he can solve 83 times 49 by multiplying 80 times 49 and 3 times 49 and then adding them together. Do you agree or disagree? Well, it looks like he's talking about grouping, okay? And if we come in here nice and tight and we take a look at that. So our original thing says 83 times 49. And he's breaking this 83 into 2 chunks, an 80 and a 3, but keeping the 49. Isn't that grouping? Ooh, it'd be helpful if I wrote the right number. The issue that we would have is if he tried to break apart both numbers. If you're going to group to solve, you can break one of the numbers into its addition parts. 80 plus 3 is 83. The other number has to stay the same. So he is correct. And then B says, would you try to solve this with a different strategy? And that's completely up to you. If you are not a big fan of grouping to solve, then maybe you could tell us what you would rather do. Do you want to do the standard algorithm for 2 by 2 multiplication? Would you rather turn this into a 50 and then multiply and then subtract 1 later? It's up to you, and I'm going to let you decide. Kaya is sorting the beads in her bead collection. She has a box with 32 different sections. Ooh, that's a nice box. She puts 19 beads in each section, so how many beads did she put in her box? Well, sounds like multiplication to me. 32 sections, 19 in each section. Write an equation with a letter, so maybe that equals B. Okay. So 32 times 19 will tell you the total number of beads. We're using a letter, okay, to represent beads. And then you solve the problem. Do I have suggestions for you? I do. I kind of think that you could do halving and doubling, to be quite honest. Let me find a space to put this down. So 32 times 19. Well, if I cut this one in half and I doubled this one, well, wouldn't I have 16 times, what's that, 38? Okay. What if I did it again? Cut that in half and double this one. Well, 16 cut in half becomes 8. And then if you double 36, you've got 76, right? Did I do that right? 38 plus 38? 16, carry the 2, 7. Yeah, okay. Now, this is a problem that I would much rather stack and multiply. If that's not how you want to solve it, don't. But in my mind, I was thinking, gosh, 2 by 2s can be so tricky sometimes. I could have done 32 times 20, gotten an answer and then subtracted one of the 32s when I was done, right? Because I would have given one more to make it a little bit easier to multiply and then get rid of one of them later. That's possible. I could group it, right? I'm going to let you use the strategy that you like the most. Kaya has another box with 46 sections. She puts 18 beads in half of the sections and 21 beads in the other half. How many beads did Kaya put in the box? Show your work. Wow. Well, if you have a total of 46 sections, and she says she puts 18 beads in half the box. Well, what's half the box? If I split this into two numbers, that'd be 23 and 23, isn't it? So she puts 18 beads in this half, so we'll put 18 times 23. And she puts 21 beads in the other half. So we have two multiplication problems. And when you're done solving it, you would then combine those answers. And since it's a challenge question, I think I'm just going to help solve if that's okay. For my 18 times 23, I'm going to cut that in half and double this one. So I would have a 9 times 46 because I just kind of like to do multiplication. How about the right multiplication? When there's a single digit on the bottom. To me, it's just a little bit easier to multiply. 9 times 6 is 54. Carry the 5. Don't forget we need to add that on this next step. 9 times 4 is 36. Add the 5. Is that a 41? I hope I'm doing the math in my head correctly. I really should not do that. I should just write it down to be sure. And then on the other side, when we're looking at 23 times 21, well, I'm going to take 23 times 20. Okay, so I'm going to get rid of this single 23, okay? The reason I'm going to do that is because I can just, if you remember, forget about that 0 for a second and just take 23 times 2. If I do that, 23 times 2 is 46. And then I can add the 0 back on, okay? So I now know that 23 times 20 is 460. The problem is that to do that easily, I got rid of one of the 23s, so I have to make sure that I add that 23 back on. So my actual answer is 483. Now that I have both of these done, I need to add them. That will be the total number of beads that I have. Okay? That's kind of a long problem, but there's so many different ways to solve it. I love the challenge questions because you get to be creative in how you solve it and flex your noodle and how you understand the math. Okay? If you have questions, please contact your local math wizard. Your teachers love to answer questions. Check you later.